Hi everyone, in today's lesson we're going to talk about arithmetic sequences. Arithmetic sequences. If a sequence of values follows a pattern of adding or subtracting a fixed amount from one term to the next, it is referred to as an arithmetic sequence. The number added to each term is always the same and is referred to as the common difference, denoted by the letter D. So for example, given these two sequences below, find the common difference and the 10th term. So looking at the pattern, 15 to 20, 20 to 25, 25 to 30, how am I going from one term to the next? You should be saying we are adding 5. So we would say the common difference, D, is 5. So if I want to find the 10th term, I'm just going to follow the pattern and count until I am at my 10th term. So we have 15, 20, 25, 30, then 35, 40, 45, 50, 55, and 60. Let's see if that's enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be my 10th term. So my 10th term, a sub 10, is 60. Okay, now let's look at the second example, 100, 97, 94, 91. It looks like the sequence is going down, and each time I'm subtracting 3. So we know that the arithmetic sequence is actually defined by adding or subtracting a fixed amount. The general rule is that we always write it in terms of adding, and that subtracting isn't usually written. So we would say, instead of subtracting 3, we would say adding a negative 3. It means the same thing. So my common difference, D, is negative 3. So let's keep subtracting 3. So 88, 85, 82, 79, 76. Let's see if that's enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. Subtract 3 is 73. So a sub 10 is 73. Okay, now I'm going to show you the formula that we can use to find any term of the sequence. So a sub n equals a sub 1 plus n minus 1 times d, where a sub n is the value of the nth term, a sub 1 is the first term, d is the common difference, and n is the number of terms. Okay, when this formula is used is when counting, just like we did up here, seems a little bit too challenging. Like, for example, it says find the 40th term of this sequence. I don't think it would be a good idea to keep following the pattern 40 times. A formula may be a better approach. So we want to find a sub 40, right? That's what it means to be the 40th term. So in the formula, a sub 40, it's equal to a sub 1, which we have as 8, plus n minus 1 times d. Now, if a sub 40 is what I want to find, if I'm putting 40 in for this n, I have to put 40 in for this n. N just means that there's 40 terms, minus 1, times d, which is the common difference. So that's the only thing left that we need to find. So we're going to say, okay, how do I go from 8 to 11? You should be thinking adding 3. So my common difference is 3. So multiply this by 3. So a sub 40 is the value of this typed into the calculator just the way you see it. So why don't you go ahead, pause the video, and hit resume when you're ready to see the answer. Okay, you should have gotten 125. That would be my 40th term. Okay, I'd like you to see if you could try number 2 on your own. So we'll make number 2 homework, and I'll come around and check it tomorrow. And let's see if we could do number 3 together. It says, what is the total number of terms in this sequence? So this sequence goes from 5 to 1 to -3, and then there's a bunch of terms in the middle, dot, 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 and then 111. So if they're asking you the total number of terms, they're asking you for the n value. So we have a sub 1, which is my first value, which is 5. We can figure out our common difference. So how do I go from 5 to 1 to -3? It looks like from 5 to 1 I'm going to subtract 4. 1 minus 4 is -3. So my common difference, D, is -4. So let's write down the formula. A sub n equals a sub 1 plus n minus 1 times D, and let's plug in what we know so far. We know our common difference is -4. We know a sub 1 is 5, and I want to find n, so I'm going to leave n alone. The only thing that we need to think about is plugging in a sub n. Now, we don't know how many terms it's going to take to get to 111. So just think of it like this. You have 5, 1, -3, something, something, something. Not sure how many times I have to do that, but eventually at the end I'm going to be at 111. So if I were to count the number of terms, 1, 2, 3, 4, 5, 6, and however many are in the middle, to get to 111, that would be the number of terms that I have. Therefore, the last term here, theoretically, is a sub n. So I can put 111 here. Now it actually should be a -111. There was a typo in here. So this last term is actually -111. And we can solve. We'll start by distributing the -4n plus 4. And we'll combine like terms. So -4n plus 9 equals -111. And subtract 9 to both sides. -120 is equal to -4n. And then we could actually divide both sides by -4. And n is equal to 30. So that means there are 30 terms in the sequence between 5 and -111. There would be about 28 of them in between here. So add them together and that gives me 30. Okay, let's move on to the next page. Alright, so sometimes the questions will ask you to find a formula that you can use to find any term of the sequence, not to create one, or excuse me, not to use one to find a term. So the following are all equivalent ways of asking this. I could say find the formula for the nth term, find the nth term of the sequence, or find the explicit formula for the sequence. So we have to keep in mind the formula to find any term that we wrote on the first page. Okay, so we're going to use this to help us find that any term of the sequence for the formula for the explicit term. So it says, given the following sequences, determine the formula for the nth term. So we first have to find our common difference. So let's look at this first one. We have 3, 6, 9, 12. It looks like my common difference, D, is 3. I know my a sub 1 is 3 as well. That's my first term. And honestly, that's all that we need. Because if we want to use a formula that we can plug into, we're going to need to keep the n values. So that's another thing. When you're doing this, you want to keep a sub n, and you want to keep n alone. So watch. We're going to keep a sub n, plug in a sub 1, which is 3, keep n, and plug in my common difference of D, of 3. And then we're just going to simplify. So a sub n equals 3 plus 3n minus 3. Combine like terms. The 3 and the -3 cancel. So a sub n is equal to 3n. That's a formula that I could use to find any term of a sequence. Alright, let's try another one. So again, the only two pieces that we need to find this formula are a sub 1 which is 18, and my common difference, in this case, 18 to 16 to 14, looks like we are subtracting 2, so that's my common difference. And we're going to plug into the formula. A sub n equals a sub 1, which is 18, plus n, we're going to leave alone, minus 1, times d, which is negative 2. Distribute that negative 2 in. And combine like terms. This is the formula that I could use to find any term of the sequence. So if you want to check to see that the formula that you made is correct, what you actually can do is just start plugging in values. So we'll try this one, for example. So if I want to find a sub 1, every time I see an n, I'm going to put a 1. And if you do that algebra, you'll get 18. That works. That's my first term. Say I want to find a sub 2. Every time I see a n, I'm going to put a 2. And it looks like I get 16. So that works as well. Keep going. So this is a great example of how my sequence worked. I plugged it in, I substituted it, and I got to see that it worked. So the next set of examples say find the explicit formula for each sequence. So finding the explicit formula is the same thing as finding the formula for the nth term. So I'd like you to try these two problems on your own for homework, this one, and I will come around and check those in class tomorrow. Alright, let's move on to the last type of questions that I could possibly ask you. So it could say something like this. The third term of an arithmetic sequence is 7, and a seventh term is 23. Find the common difference. So let's map this out. This is my seventh term, so we'll call this a sub 7. Oh, excuse me. We won't say a sub 7. It says here, this is the third term of the sequence is 7. So we'll say a sub 1, a sub 2, a sub 3, and we'll say this one is a sub 7. So I know this is 23, and I know the third term of the sequence is 7. So the question asks us to find first the common difference, then the first term, and then use that formula maybe to find the 15th term. So let's see what we could do here. We don't necessarily know the first term, but we know that in order to go from 7 to 23, I'm going to have to find a pattern. So I know that it's 7 plus some common difference would give me this number. Then this number plus that same common difference would give me this number. Then I'd have to do it again, plus d, whatever that d is, to get to this number, and then one last time to get to 23. So I know that en route from 7 to 23, I have to add 4 d's. So from here to here is 4d. So you could actually write an equation. 7 plus 4d equals 23. And then you could subtract 7 and solve. So 4d equals 16. Divide by 4. D is equal to 4. So that helps us find our common difference. Now let's see if it works. Take 7, add 4. That'll give you 11. Add 4 again. That gives you 15. Add 4. That gives you 19, and then add 4, and that gives you 23. So now it's actually very easy to find the first term of the sequence, because all I have to do is work backwards. If I added 4 to get to 11, I'm just going to subtract 4 from 7, and I'll get 3, and then minus 4 again, I'll get negative 1. So to answer the question so far, part A, the answer is D is equal to 4. Part B, the first term, a sub 1, is equal to negative 1. And then a sub 15, find the 15th term. We could write a formula, but it may not be a bad idea to just keep counting. So we have, we'll say part C is a sub 15. So we have the 7th term, 8, 9, 10. 11, 12, 13, 14, 15. So we know, like I said, the 7th term is 23. So this is 7th, 8th, 9th, 10th, 11th, 12th, 13, 14, 15. So we're just going to add 4 each time. So 23 plus 4 is 27. 27 plus 4 is 31. Then 35, 39. Then 43. 47. 51, 55, and that's it. 55 is my A sub 15, my 15th term. Okay, let's see if we could do number 2. I'll help you set it up and then you're going to finish it. So it says, what is T sub 1 of an arithmetic sequence for which the 10th term is 41 and the 15th term is 61? So we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we know the 15th term is 61. So we'll say this is T sub 15. And we'll say T sub 10 is here. So let's just check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Good. So we have to figure out the same way we did before, the common difference first. How many times am I adding D? Add D here. 1, 2, 3, 4, 5. So let's write that in. We're going to add D here, 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 and here. So this is 5 D's. So the formula that we're going to write is 41 plus 5D equals 61. So we'll subtract 41 on both sides and get 5D equals 20. Divide by 5 and we get that D is equal to 4. So using that information, can you work backwards to tell me what T sub 1 is? This is my answer. Alright, so I'm going to let you finish that and we'll go over it in class tomorrow. Alright, have a good night.